Now we're going to talk about z-scores. So z-scores you'll also see referred to as standardized scores. And these are a good way to compare two things that have different means or different standard deviations. The ones that we're going to start with today actually are not going to have different means or standard deviations, but we'll do some in class that do and use the z-score as a basis for comparison. So the z-score formula is important. You're actually going to have to memorize it. And I'm going to give you the formula, then I'll explain what it is. So it's going to be x minus x bar over s. And in this case, my x bar is going to be my mean. My s is going to be my standard deviation. And my x is going to be my observed value. And I'll give an example to explain how to actually use that formula. So we're going to start by comparing the Yankees and the Mets. And in 2011, the mean number was 81, so that's our x bar. The standard deviation was 11.9, so that's our s. We are going to find our z-scores using that formula. So for the first one, our observed value for the Yankees was 95 wins. So we're going to write this as z equals 95 minus 81 over 11.9. And when you work that out, you should end up getting that z equals 1.18. So what that means is that the New York Yankees were 1.18 standard deviations above the mean. So that's pretty good. You'll notice sometimes you're going to have positive z-scores, which means that you're above the mean. Other times, as you might be able to guess with the Mets, you will have negative z-scores, which means that they're going to be below the mean. So if you want, you can fill that in on your own, but I'll quickly write it out for you also. So the Mets had 74 wins, the mean is still 81, the standard deviation is still 11, and their z-score is going to be negative 0.59. And you might be able to guess that that means that the Mets were 0.59 standard deviations below the mean number of wins.